DMSE, the Department of Material Science and Engineering here at MIT, is the academic home where we educate tomorrow's leaders in how to make solid matter. We are builders. We are equal parts scientists and engineers. We study how to move atoms around, how to assemble them into unique structures to evoke interesting properties. And we learn those scientific tools so that we know how to make things, so that we can engineer solid matter.
Some of the key areas in the department include research on energy. We have a lot of energy research going on, battery development and so forth. We have a lot of work on electronic materials, optics, photonics, magnetics. We have work in biological materials, including tissue engineering. An exciting development is Professor Fink's work on optical fibers, where he's developed fibers that can transmit light and can also be used as sensors and in medical applications. So you can actually treat tumors or perform surgery by shining radiation down a fiber and using that to treat the illness.
In my laboratory at MIT, in the Material Science and Engineering Department, we explore new kinds of semiconductor materials in order to build devices and integrated circuits that will have an impact in society. We've already had some previous success with strained silicon, which is in your microprocessor that you have today in your laptop. What we're doing is trying to build even a more advanced combination of materials and demonstrate integrated circuits that really would take the semiconductor industry in a whole new direction.
Hands-on learning is at the heart of how we believe material science and engineering should be taught. The discipline of material science and engineering is the discipline where the connections happen, right? It's where the chemists and the physicists and the mathematicians and the biologists want to work with engineers, and where the engineers want to work with them, and it all comes together in this discipline, which I think is what's needed in order to make an impact in materials.
The curriculum in DMSE is centered on the principle that education should be hands-on. From the moment when students declare their major as material science and engineering, we put them in the laboratory and we make them use their hands. From day one, they're learning how to operate microscopes, how to measure fundamental properties of materials, and how to build using materials. Our lectures are intended as supplements to the hands-on education, and through their entire curriculum as undergraduates, the focus is really on the laboratory work.
We have labs in the department that cover all of the areas of materials. There's a blacksmithing lab, there's a glass blowing lab, there's a foundry. We think it's important for students to actually be able to process metals, and this gives them the chance to pour metals and shape metals, and it's really one of those things that you can't learn out of a book. We actually make a set of cast medallions every year which we give to the graduating class, and the undergrads and grad students participate in making those medallions. So that's a nice memento of their time in the department.
DMSE is proud to have a suite of laboratory facilities that are located right here on the Infinite Corridor, which is the backbone of MIT. This fosters a lot of interactions with our peers, a lot of collaborations, and it gives our students excellent exposure at the center, at the heart of the Institute.
I think the physical space at MIT is very important. As students pass by and other faculty, they see what's happening inside of these labs. They see students actively taking part in experiments, and it fosters a sense of interdisciplinary interactions and collaborations.
In DMSE, we are beginning to explore the use of online tools as a way to enhance our own students' educational opportunities. For example, in the coming year, we're hoping to launch what we call the Semester from Anywhere.
The Semester from Anywhere is being implemented by putting 3 classes online that are undergraduate electives here in the Material Science Department. And once those are online, then it gives a student complete flexibility to pursue any project they want to do outside of MIT and still be able to take those 3 classes which help them stay on their degree program schedule. The experience they pursue does have to be about material science. That they could work in a company and get experience there anywhere in the world.
I think MIT's Department of Materials Science and Engineering is a great place to study this subject because we have a big department. We cover a lot of ground in the area of materials science and engineering. We have a very integrated program for the graduate and undergraduate students. So the undergrads are involved in research through their internships and their projects, and they work very closely with the faculty. So we think it's a great place to learn about materials science and engineering because of the opportunities of combining education with hands-on research.
Materials science and engineering is a central and important part of MIT as a whole. This is because materials are frequently the most limiting aspect of frontier technologies. They also are often controlling when it comes to societal issues like the environment or energy. So materials really occupies an important central part of the mission of MIT as a whole.